So he taught adjunct for 4 years. JW and I went through the Adjunct Academy together the very first year. There were like 6 of us, I think.
Yeah, it's
right?
very small.
So very different, but foundation was laid. JW also co-authored a chapter with Lindsay and I on the experience of the Adjunct Faculty Academy. So he's invested in this project. He's invested in the work that we do here. Let's see, he also won Adjunct Faculty of the Year, didn't you?
I did. Well, of the semester.
Of the semester.
I think they did it first semester, yeah.
Yeah, so for Gateway 2 years ago?
Yeah, I think so.
And amazing, we're also highlighting another Adjunct Faculty Award recipient, Janelle Black Beltram. She'll be here next week, or next month. So JW, let's see, what can be said about him? He's worked with Shannon Ruth, his division chair, to create the Power Math Camp. I'm sure he'll talk to you a little bit about that or explain it, because I don't know much about it. And he is constantly looking to be better in the classroom, especially using technology. So this is a great day for him to join us. He's going to be videoing himself so that he can show the lesson that he's doing to his friends and colleagues. And other than that, I really just want to turn the floor over to JW because he is here to teach us some math. So I think that'll be great. So thank you, JW, for joining us.
Right.
Let's see, Shannon asked me to mention, it's not Shannon, Summer, about the Power Math Camp. Power Math Camp is a really great tool that the math department has where students can come in for free, short boot camps. And it preps them to kind of refresh their memory before they actually take their classes. That will help them be more successful in their class. Or they can do Power Math Camp before they take the AccuPlacer, which is a big deal. If a student comes into Gateway after years of not being a student and they take the AccuPlacer, you can imagine what's going to happen. Oftentimes they bomb the test and then they get placed into 081 or 091, which is a developmental ed course which gives them no college credit. And they have to pay tuition to pass those courses before they can finally take Math 120 or some course that actually gives credit. So the Power Math Camp is really helpful and a ton of fun. Was there something else you did? No, maybe that was it. So I have an idea that I want to share with you today, but I thought I would start with 2 math word problems that you can talk about just real briefly with your table buddies. They're really just 2 jokes. I actually start every of my classes with a joke. So here's the first joke you can discuss real quick. If you have 10 apples in one hand and 5 apples in another hand, what do you have? Go ahead and discuss with your table buddies.
Yeah. You don't have a fruit salad because it's apples.
All right, that's it. Come back, everybody. Come back. You got a moment to share your ideas. If you have 10 apples in one hand and 5 apples in one hand, what do you have? Really big hands. Right? All right. Here's one more joke for you all, because I love this one. You might have already heard it. There are 30 cows in a field and 28 chickens. How many didn't? I'll say it one more time and you can discuss with your table buddies. There are 30 cows in a field and 28 chickens. How many didn't? Go ahead.
2. Chickens, right? You get breakfast, right? 2 are chicken. 2 of those cows were chicken. Yeah. Not brave enough. It's a stump.
Okay, everybody come back together again. So there were 30 cows and 28 chickens. How many didn't? 10 cows. Because there were 30 cows and 20 of them ate chickens. Oh. So how many didn't? 10 cows didn't eat chickens. All right. So those are 2 of my favorite jokes. Anyway, that was just to get us all warmed up and ready to go. I hope my micro teach only starts now, so I think I have 15 minutes. So I'd like to talk with you folks about identifying false beliefs in students. That might sound funny to hear the word belief when it comes to mathematics because it's not about beliefs, but it really is. Students have lots of beliefs in their head about what's true and what's not true. So I want to motivate this idea by saying that we often believe that if we simply construct the best lesson possible, our students will learn. Don't we all believe that? Like, oh, this lesson is awesome. Oh, this is the best lesson ever. My students are all going to get it. My lesson is awesome. But sometimes we actually have to first deconstruct the false lessons that they've learned so that they can actually learn the true lessons. So there's some deconstruction that has to go on. This makes us like Sherlock Holmes, and so that's why I put up Sherlock Holmes here. We have to get inside the student's mind, find the false beliefs, and then tweak them so that they have the true beliefs about how to do mathematics. So I bet you're all familiar with the recent Sherlock Holmes, but I just wanted to point out that Jeremy Brett is the best Sherlock Holmes actor in the history of the world. So if you want to watch Sherlock Holmes, go watch the Jeremy Brett. And that's my dad standing at 221B Baker Street. I was taking the photo. We like Sherlock Holmes. So I'd like you all to go ahead and try to be Sherlock Holmes right now. These are 4 errors that students have made in my presence. Not just one student, many students make these errors in my presence. And I'd like you to figure out, why did the student do it? And the key thing I want you to know is that I assume, you know the word assume, I assume that most errors are not mistakes, okay? These students didn't make a mistake. A mistake is like this little inconsistent thing you do every once in a while, like oops, I dropped a negative, or oops, I transposed 2 digits while typing it into a calculator. These are mistakes. These are the result of false beliefs. And in fact, these are incredibly consistent false beliefs. Students consistently use false beliefs over and over and over in a consistent way. And that's actually the silver lining here. We don't have to teach students to be consistent. So humans are all consistent. We're very consistent. We'll do the same thing over and over and over again. So the good news here is, once you find the false belief and then change it to a true belief, they will consistently do the right thing over and over and over again. All right, so what did the student do? And my question to you is, what rule were they using? Like if you were talking with a student right now and you saw them write down 10 minus 30 equals 20, what rule were they using? Who'd like to volunteer a guess? Hazard a guess. Yes, sir.
I don't know how much about the rule, but maybe they were solving as you read from left to right.
Solving as you read from left to right.
Yeah.
So 10 minus 30 equals 20. Why would the answer be 20?
That will be really interesting to observe, but every time that I'm teaching that kind of math, I like to draw a segment.
Oh, like a number line.
When I start with 0, and when I have 10, and I subtract 30, it's going to the other side of the 0, which is negative.
Of course, and that's a really good true belief that you can give to a student. You know, showing them the way to think about it. So, but why did the student say 20, Megan?
I think they were thinking about the difference between the numbers, not that we're taking 30 away from 10.
Yeah, more than likely they were thinking about the difference between the numbers. You know, the difference between 30 and 10, they're 20 apart. Yes, sir?
The rule that they're using might be that the negative sign is assigned to the 10, the number left of it, and the number to the right.
Oh yeah, they might have accidentally put that minus sign over on the left-hand side. Yeah, they could have done that.
It's because we tell our elementary schools to subtract the smallest number from the largest number.
That's another rule they can be using, the smallest minus the largest.
Yeah.
And now, one more belief, and then we'll move on. Yes?
Sorry, well, even when it's taught how to do 10 minus 30, it's taught you do 30 minus 10, and then you take the negative from the bigger, or you take the sign from the bigger number.
Yes.
So if they forgot that part.
Yeah, they
Didn't know that part.
Yeah, they didn't apply the negative. Yeah. Now, folks, these are all excellent possibilities, and now I'm going to tell you the actual belief that my most recent student had for saying this, and it's fascinating. We were sitting together tutoring, and this student typed into her calculator 10 minus 30, and literally the calculator said negative 20, and they wrote down 20. And I saw them do this. I said, oh, you know, what did your calculator say? What did you just write down? They said, well, the calculator said negative 20. But the answer is 20. I said, but the calculator said negative 20. And they said, oh, sometimes the calculator will say negative, but you just write down 20. And to me, I thought, well, this is fascinating, right? And so I drilled the student further. And in fact, they used to do inventory practices, okay? This was a definite belief they had. And in an inventory, let's say you need to have 50 widgets on hand at all times. You need 50 widgets in your inventory. And today you look, you have 70. So how many more do you have than you need? 20. You have 20 more than you need. Now, what if you're doing inventory and you need 50 widgets, and you look in your inventory, you only have 30. How many do you need to order? 20. Either way, the answer is 20. I either have 20 more than I need, or I need to order 20. And the context of industry, that makes total sense. Yeah, that they would just drop the negative because the negative doesn't matter. So that was a fascinating one. Not all my examples will be that long, but I hope that really got across to you that that was not a mistake. That definitely was not a mistake. The student did it on purpose, and they believed the answer was correct. Okay, how about negative 5 minus 5 equals 10? What is the belief that they have in their mind? Yes, sir.
Well, you know, it's two negatives make a positive. It doesn't always make a positive, but they just kind of applied that generally.
They did. And folks, did you hear how he said it? He said it perfectly. The worst rule in the world. Two negatives make a positive. In what context? Certainly not every context. That rule, as stated, and I'm so glad you said it that way, is so gloriously vague as to be unhelpful and damaging. Right? That's not the rule. Two negatives make a positive. The rule is a negative times a negative makes a positive if you're doing multiplication. But in addition, a negative and a negative is more negative, right? So they had the wrong belief in their head. Not just the wrong belief, but a vague belief that they really weren't sure how to interpret. Okay, how about this next one? 2 parentheses 5x plus 4 is 7x plus 6. What false belief did the student have? Yeah, they were just adding, right? Now, you might say, no, what student does this? No student. No, I see many students do this.
We don't, yeah, we know.
You what?
We know they do things like this, yeah.
Yeah, and even more fascinating, more than once, I have seen a student multiply the first one and add the second one consistently. Not just one student, I've seen many students do this. That's a false belief, it's not a mistake. Okay, and then the last one, my favorite, 10 minus 2 plus 8 equals 0. What false belief did the student have?
They applied the negative throughout.
Maybe they applied the negative throughout. That's a possibility. They did 10 minus 2 plus 8. That's possible. Like there were parentheses there, and they just didn't realize it. Yeah, okay, that could be. Megan?
PEMDAS.
Yeah, they could have been applying PEMDAS, and you're saying, well, I hope they applied PEMDAS. I mean, PEMDAS is how you do arithmetic. But how did they do PEMDAS incorrectly?
Because multiplication and division and addition and subtraction are supposed to be done in the order that you see them, not in the order that it's in PEMDAS.
Yeah. See, unfortunately, students learn the word PEMDAS, and they treat it like gold, and they think addition before subtraction. And any student who learned addition before subtraction, obviously, you would do 2 plus 8 is 10, and then 10 minus 10 to be 0. Unfortunately, it's not addition before subtraction. It's addition and subtraction from left to right. So again, none of these students made a mistake. Not a one of them. These were errors, but they weren't mistakes. They were false beliefs. So only after the student describes their false belief to you, will you know how to update their belief system. So once you identify a false belief, what do? One, you need to give the student the correct belief in a complete sentence and make them say it back to you. So you, sir, gave a great example of a negative and a negative is a positive. You would want to restate that into a true English sentence. In multiplication, a negative times a negative is a positive. And that'd be a complete sentence, and then they'd have to repeat it back to them. So here's my example of what I did with my student who said 10 minus 30 equals 20. I said a small number minus a large number is physically impossible. Right? If you have 10 sheep in a field, not cows and chickens, if you have 10 sheep in a field, can you take away 30 sheep? No, it's physically impossible, right? So I'll have all of you repeat after me, just like I would have my students. I'll say it first. A small number minus a large number is physically impossible. Everybody go.
Small number minus a large number is physically impossible.
Which is why the answer is negative.
Which is why the answer is negative.
Yeah. And now they have a complete sentence they have in their head. They've said it once. They have muscle memory in their mouth. They're more likely to remember this true rule now. They're more likely. It probably takes more practice, but they're more likely. Okay, how about negative 5 minus 5 is negative 10? This one is a doozy because of all the false beliefs they could have in their head right now. There are actually 3 similar beliefs. So take a look at each of them. The first belief could just be that a negative times a negative is positive. That's one belief, but they have to distinguish that from the other possibilities, such as negative 5 minus 5 is negative 10. That's a different context entirely of subtraction. And finally, you could have 5 minus negative 5, which is a genuine negative, a double negative, in which case you get a completely different answer. So with a student like this, you would have to go through each of those rules and separate them out so they can clearly see each one, and then give examples as well. So like when I say a negative times a negative is positive, I would give them another example to go with it. Similarly, a negative divided by a negative is positive. I think that one's actually more obvious. Why is a negative divided by a negative positive? For instance, if I have negative 5 divided by negative 5, what's the answer? It's 1, right? Because anything divided by itself is simply 1. So that's one way that you could separate that out. That definitely a negative divided by a negative is positive, and also a negative times a negative is positive.
Just put it into a multiplication sentence, like negative 5 times 1/5 negative 1/5, it will be 1.
You could do that as well. Yeah, so there's a lot of ways that you could give them the correct belief. Let's see here. I suppose I could go through more of these, but I will. You want to give examples. So like this -5 minus 5 is -10. I would give examples. Like if you spend $5 and you spend $5, how much money have you spent? You've definitely spent $10, right? And I point that out to them that if you tell me that you spend $5 and you spend $5 and now you magically have $10 in your pocket, you know, that's magic. That's it's just not possible. Likewise, yeah, that one's a good one. This one's even better. If you go left 5 steps and then you go left 5 more steps, where are you?
10 steps further to the left.
Yeah, you're 10 steps further to the left. Now, obviously, you guys watch me move to the right. That would not be a good example to use because that would be confusing. But yeah, you're obviously more left. Now, this last one is really exciting, a double negative. See, a double negative is when it goes 5 minus -5. What do you notice about the negative signs?
Next to each other.
They're next to each other. And I tell them a double negative is 2 minus signs in a row, literally touching. They have to literally touch. And I like this example, don't not eat your vegetables. Because it points out that the placement of that negative is very important. If I say don't not eat your vegetables, what does that mean? Eat your vegetables. Now observe, don't eat your non-vegetables. What does that mean? Don't eat your non-vegetables.
Don't eat
Yeah, well in this case, you don't really know if you should eat your vegetables or not, but you shouldn't eat anything that's not a vegetable.
Yeah.
Right, and that means something different. Don't eat candy, for instance. And now here's another one. Don't eat vegetables that are not yours. Right, now again, the placement of the not changed everything. So now you should eat vegetables, but don't steal them from other people. Right, okay. So these are all beliefs that you have to give them the correct beliefs so they can do math correctly. So I just wanted to share where this came from, why I think about this. One is I'm a lifelong math nerd. I've been doing math since the womb. And anytime I get a problem wrong, it drives me crazy. I'm like, ooh, why didn't I get that problem right? What didn't work? So I'm always thinking about my own mistakes or false beliefs and trying to figure them out. Next, I did a lot of tutoring in college. And tutoring is an excellent place to meet a lot of people who have false beliefs. And so that was very interesting and enlightening to me because as a high school student, I was in accelerated classes. I wasn't really interacting with a lot of people with false beliefs because we all got A's. So it was really enlightening for me to be tutoring to see, oh my gosh, people have a lot of false beliefs. And then I started tutoring at Sylvan Learning Center. Now there was a shocking amount of false beliefs. Because you know, Sylvan Learning Center is where students go who are in the most trouble. They're failing their classes, their parents are very concerned. These are the students who are most at risk and they have the most skill gaps. So while working at Sylvan, I just couldn't believe it. It changed my whole perspective on how to teach math, about finding these false beliefs. And for a while I was an online math teacher. That was tough. As an online math teacher, you can't really talk with students back and forth to figure out what their false beliefs were. So that was a little frustrating for me. But then as a high school teacher, I saw the light. It was glorious. As a high school teacher, I got to force students to interact with them. I could force it. I got to force any student I want to come see me after school. I talked with administration. I said, little Billy and little Susie, they need to come work with me after school. And they made it happen. I emailed the parents. I said, your little Billy and little Susie, they need to come work with me after school, and made it happen. I could force students to come in to see me after school, and I thought, wow, now this is good. This is real teaching. I am really making progress with these students who would otherwise just be struggling. So finally, I was an adjunct math teacher at Gateway, and there I also had some struggle. I thought, how do I interact with my students? I don't have an office. I don't feel like I can force them to come see me, and I struggled with that for a while. Until finally this year, I became a full-time teacher at Gateway, and I decided I'm just going to do it anyway. I'm just going to do it anyway. So this is how all of this came together for me this semester, my first semester at Gateway, full-time. How does it affect my practice? I created 2 new office hour policies, which I've never had before, and I don't think I've ever heard of anyone else doing this. But I love it. I'm going to share it with you. First, between my second day of class and the day of the first exam, you must come visit my office for a 5 to 10 minute conversation. This is all of my students, all of them. They must come to my office. We'll review your notes that you're taking in class, we'll review your homework, and this requirement will count as 20% of your first exam grade. So that's that. If they come in and they take their first exam, they get the score they earned. So let's say a student takes the first exam, they get 100%, and they already came and talked to me, they get 100%. But let's say a student They don't need to come in and see me. They take the test, they get 100, but they never came saw me. I take off 20% and they get an 80%. So I force all of my students to come see me. And this was my first semester doing it. And do you know how many of my 100 or so students came and saw me? All of them. All of them came in and saw me because they didn't want to lose that percent. Now, it's true, I did have to hound a few of them. I had to go chase after them. I'm like, you know I'm going to take off 20% if you don't come see me. But they all came in and it was great. Okay, my second policy, and this is where I really capture all those students who are struggling, is that after each test, if you score below a 70, so any student who scores below a 70, I will record your grade in the grade book as a 0 until you come to my office to review your test with me, the entire test. We're going to sit down and review every single problem that they missed. Expect this office visit to take 15 to 30 minutes, usually 30 to 60 minutes. And once you've reviewed your test with me, I enter the grade you earned. So if they got a 50%, they get a 0 until they come see me. And then they come see me, we review all the questions, and then they get their 50%. Now, that might sound harsh, like, geez, that's rough.
Sounds time consuming.
Well, for me, maybe. For them?
Yeah.
Well, for them, it's changing their life.
No, for you.
Yeah, well, yeah, it does. That does take up the bulk of my office hours. But hey, what else am I going to do? They're my office hours. So, but it does change their life. I ask every student, was this valuable? And they're like, oh my gosh, like, it's so obvious. And I tell them, the reason I do this is so that if you had the chance to take the test again, what would you get? What would they get? They'd probably get an A, right? The second time around, they get an A.
So you don't increase their grade on that second one. They get the grade that
they get the grade there.
earned.
Yep. Yeah, and you know, a lot of them beg for extra credit. They're like, I came in, get it. And I'm like, no, that's not the policy.
Some points are better than no points.
Yeah, exactly. It's better than a 0. Yes?
Have you tried giving them the same topic exam again? Like, I don't know, next week, the same topics?
You know, with many of them, I give them a blank copy of the same test or the practice test, and I say, go home and keep doing it until you can do it. Yeah, now if they actually do that or not, I'm not sure, but yeah, that's what I do.
So when is your first exam?
It's like after the first month. So they have a month until the first exam, yeah. All right, so this is what I do, and my encouragement to you is to go ahead and go for it. Try it out. I realize it might be tricky because you don't necessarily have an office per se, but there's adjunct offices in whatever building you're in, and or you could choose to meet before class or after class. But by forcing this issue, you get to force the idea that you get to interact with all of your students and start helping to identify their false beliefs. So I have no idea what time I'm at. Okay, so I'm wrapping up here, folks. So my encouragement to you is, it's so easy to feel frustrated with a student who's asking a dumb question. And it's so easy to feel frustrated by a student who's making that same obvious, silly mistake in front of you. It's so easy to feel frustrated. But I really encourage you to resist that temptation. Just because you have explained a concept 1 billion times doesn't mean that they have ever understood it. They have never understood it. You've explained something 100 times, they never understood it. And it's probably because they have a false belief that's stopping them from understanding the words that are coming out of your mouth. Right? So they literally don't understand you. So instead of explaining it again and again and again, stop talking, stop explaining, and ask them questions. Right? You can say, what would you do? What would you try? Why would we do that? Why does that work? Why not try it another way, and would that work in another situation? What you want to do is draw them out. You want to have them go ahead and just explain to you what they're thinking, because then you can say, aha, there's that false belief right there. And then we can tweak it and set you on your way with the real idea. So once the student has fully described their false belief, you'll know how to update their belief system and then give them a correct belief in a complete sentence and make them repeat it back to you. So finally, how to increase one-on-one time. So how can you make this happen? Do the mandatory office hours. Just go for it. Make it part of their grade, and you know what? The students will come along. They'll do it because they want the grade. 2, multiple times per hour, walk around your room to observe student work. And while you're just walking around the room and you catch a mistake or an error, you can just have a quick conversation with them about it right then. And now you're building it into your class time. And then finally, when a student asks you to solve a problem, and they always do, right? They raise their hand like, will you do the homework problem number 5? I always say, thank you for volunteering to do that problem for us. That's very brave of you. Go ahead, solve that problem for us. And then I have them walk us through the problem. And you can use the Socratic method to help them out as they do it. And then finally, during lecture, point out as many false beliefs as you can. So as you're going through a problem, you can just say, oh, here's a common misconception. Or this is a mistake I regularly see. And then ask them to explain why it's a false belief. And you'll learn so much from them. Yes, sir.
Where did you gather the misconceptions? Through literature review or through experience?
Just experience.
Okay.
Although there is a book, I tried to find the book title before I came in today. There's a book where someone wrote a book exactly about this. And he just walks through chapter after chapter of mistakes people have made. But I totally forget the title. If I can find it, I'll send it to Summer or Lindsay, and then they can send it to you.
Because in geology, there is one article that is like 50 pages long about the 500 misconceptions in geology. And I'm asking you because someone just put it together and they're like from 8th grade to 12th grade, these are the misconceptions from first year to third year undergrad, these are the misconceptions.
And there is a math book like that, and just imagine if we had made all of our math students read it. Then they could read for themselves what the mistakes were. That'd be great. Yeah?
I had a question. So, like, for example, every once in a while I'll work with a student and I'll point out the false belief. So, like in my public speaking class, right? They'll say a big idea that is just patently false.
Yeah.
Like you just look at the words and it's just patently false, or main point patently false. And so I'll sit down with them and I'll point out to them. I go, do you really mean all? Do you really mean that if you do this, your whole life will be amazing? Or what do you actually mean? And so when I've done stuff, not to the degree that you're doing, but when I've done it, the struggle is I sit there with them and I say, so what do you really mean? And I think, I don't know if they know what they really mean. Maybe they really do mean what they wrote, but they don't come up with something more reasonable. And then I struggle because I'll then do this after 5 minutes. Well, do you mean something like this? And they're like, yeah. And then they'll write it down. I go, no, that's just rough draft language. Think about a better way to say it. But I worry that I end up just giving them the answer and then they didn't, not the answer, but I figured out the wording for them and I didn't help them. Any thoughts on, because that's a communication context for it.
Well, I'm not an expert in writing, but listening to what you just described right there, that reminded me a lot of Socrates. Socrates had all the right answers. He could have just went around telling everyone, but he drew it out of people. So, I like the idea of you forcing the student to come up with a counterexample. You're saying, this is always true. Can you think of a counterexample?
Yeah. And they see that there are counterexamples, but then, okay, now word it in a way that represents something more reasonable or based on the evidence or whatever. And they have the hardest, they sit there for 5 minutes.
Yeah.
And then I oftentimes just end up saying, well, how about this?
We know you could do, okay, this is just me just thinking.
Yeah.
You don't want to give them the verbiage, right? It's their essay.
Right, exactly.
So you could just switch into a different context and say, let's say I'm writing an essay about this. And then, you could say it this way, but this would be a better way of saying it. Now, how do you apply this idea back to your paper?
Yeah.
That way you're not just giving them the verbiage, but the thing is, they do need the correct belief. They might literally not know how to say it the way you're suggesting it because they've never conceived of the idea before. Yeah. And so, they probably do need you to hear it said. But maybe you could say it in a different context, so not to give it away. Yeah. But that's a really good question. I don't think I'm the expert in that.
Yeah,
but,
that was
fun to brainstorm. Yeah. Yes?
I don't teach math, but in looking at your presentation, one of the slides you gave examples, I see those examples as almost like miniature case studies.
Yeah, they are case studies.
Yeah, so in every one of my lectures, I have case studies embedded in there. So I'm lecturing, then we get to a case study, and these are longer case studies because they deal with like business and things like that. But these are kind of like micro case studies where you're helping them understand these concepts based on real life examples. And you're saying if I move 5 to the left and 5 to the left more, what just happened? They're answering the question for you, and then it clicks.
Yeah.
So I feel like whether you fully invest a lot of time in case studies or do these kind of micro case studies, that might be a good way to kind of let it sink in.
That's a really exciting idea. Like if every day I started a class with a case study on the board, and that's the riddle for the day. Like I tell a joke at the start of every class, but that'd be a good idea too, to have a false computation and then have them figure out the right way to do it. That's a great idea. I love it. I'm going to start doing that.
I do that in programming.
Oh, do you really?
Yeah, I put up a program and say debug it. I made like a ton of mistakes.
Oh, that's
ask
fun.
for a volunteer to come and debug the program. When I'm walking around, I see the mistakes they make.
Yeah.
And so all those mistakes are up there.
That'd be a great test question too. A test question could be a completely incorrect computation, and then they have to go and fix the whole thing. Really fun.
Yeah. Just a suggestion, you might want to have a couple that are actually correct. That way, they do have the wrong.
Yeah, they say, well, actually, that one's fine. Yeah, that's really fun. This is really good. Yeah?
Online, I had a demonstration problem and I actually make mistakes in it. And I suggest that they write me with what the mistakes are before I let them into that module. So.
Oh, before you even let them in. Oh, that's great. It's like a gatekeeper. That's really fun. Folks, this is wonderful. Thanks for sharing all of your ideas with me today. I'm glad I got to come in so that you could give me ideas about how to improve my own classroom. This worked out really well. Yes? Oh.
I have one last question.
Yeah.
I think it's maybe a difficult question for everyone here in the classroom, but in your context, what do you do with your students that even after you're working with them, they seem to just not care?
They don't care?
I just don't care.
Gosh, I honestly can't even conceive of that.
They're there and they're paying money to be there, but at some level, it's like can't get to them, can't get them to engage with you.
Yeah.
They don't care.
Wow, I mean, that's a deeper question. I'm thinking about all my students who I have right now, and I only have maybe these 10 who I'm constantly working with in office hours. All of them do care. So yeah, gosh, I don't have a response to that one. I mean, students can choose to fail, right? Students can choose to fail. And from time to time, I do have, maybe 1 student, 2 students a year who just choose to fail. There's nothing I can do. I send them emails, I call them, they still choose to fail, and that's their choice. Yeah, I wish we could save everybody, but I don't know. They can choose to fail. That's a good question. All right, thanks, folks.